All right, so we start chapter 3. Chapter 3 talks about parallel and perpendicular lines. And so we will revisit Algebra 1 a little bit when we start writing equations of lines, but we're obviously going to dive a lot more into parallel and perpendicular lines in the form of geometry. So for today, a couple things we're going to hit here. One, by the time we're done, you should be able to identify pairs of lines and some angle pairs, some new angle pairs, as well as talk about what happens with those angle pairs when some of the lines that are making them end up being parallel, and so we'll get into all of that. First and foremost, what we mean by pairs of lines, right, is that we have parallel lines, so we have to have a pair of lines to be parallel. We know what parallel lines are. They're lines that do not intersect. They're lines that don't touch. But we add in the fact that they are coplanar as well. And we do that because skew lines also are two lines that do not intersect. But they are not coplanar. And so we're going to have to tell the difference between those two. Okay? Two planes that do not intersect are called parallel planes. Okay, maybe the floor and the roof, the floor and the ceiling in the room that you're sitting in right now, those would be parallel planes. Okay? Now, as we're writing and trying to assume some things from diagrams, some things we need to be aware of. First of all, this double pipe right here basically means parallel. So if I want to say that line CD is parallel to line AB, then I would use that parallel symbol. Okay? In a diagram, if we're going to assume what we have to see in order to know that two lines are parallel are a set of arrows. So on a set of lines, if they have the same number of arrows, then they're going to be parallel to each other. Now we can have multiple sets of parallel lines and therefore keep adding arrows. So any sets of lines that have the same number of arrows are meant to be parallel. We've seen this symbol before with perpendicular. Right? So if I want to say that line CD is perpendicular to line AB, then we would use that upside down T to mean perpendicular. How would you know in a diagram that two lines are perpendicular? Well, we use the right angle box because we know that two perpendicular lines make right angles. So you have to see that right angle box there to assume that two lines are perpendicular. Okay? So let's use this cube to help tell the difference in some of the definitions we just saw. Okay? Lines parallel to CD, to line CD, we want to find a line parallel to line CD and contains point A. Okay? First of all the lines in this diagram that are parallel to CD, they're in the same plane. So if they're going the same direction, then they're going to be in the same plane, like line EF, or line AB, or line HG. All those lines are parallel. They're in the same plane, and they're going the same direction. The only one that does that and has point A in it is line AB. Okay? Now we need a line that's skew to line CD and contains point A. Now skew needs to not touch, so it can't be any of these guys. Those are all touching. But cannot be coplanar, so it can't be any of these guys because they're all in the same plane. So basically, to find two skew lines, or to find the line skew to line CD, you need a line that's going a different direction and is not going to touch it. So this line and this line are going in a different direction and not going to touch it. This line and this line go in a different direction from line CD and are not going to touch it. And then you also have line AG through here. It's going a different direction and not going to touch it. So you have a lot to choose from. But we need lines that have A in it. So it's going to be line AG and line AH, either one of those. Okay? Now, next one. We need a line perpendicular to CD that contains A. Remember that we have to have a right angle box to remember that we have to have a right angle box to assume perpendicular. So perpendicular to CD is this line right here, and that also contains A. So line AD is that line that we're looking for. And now we need a plane parallel to plane EFG. The EFG is down here. We need a plane parallel to that one that has the point A in it. Well, that's going to be this plane up here. So plane, make sure you write the word plane, ABD, BAD, DAB, anything like that, or using the point C would be fine as well. There you go. Okay. Hopefully skew lines make sense. Those are the ones that can be kind of tough. All right. Now, with parallel and perpendicular lines, there are a couple of postulates. The parallel lines, basically, it's knowing that two lines are supposed to be parallel helps us create a line. So if there is a line, so line L here is an existing line, and a point not on the line, then there's going to be only one line that goes through point P that is parallel to line L. So in this picture, there is exactly one line through P that's parallel to L. Same thing with perpendicular. If you draw a line and then put a point that's not on the line, like this, line L and point P, then there's exactly one line that goes through P that's going to be perpendicular to L. Okay, that's what these two postulates say. Fairly obvious, but we acknowledge them so that we can possibly use them later. Okay, an example of this stuff in the world around you. All right, so this is a couple of streets in Niagara Falls, New York. Now you might need to darken in some of your lines, right? So let me relabel these. Understand that point A is right here. Point M is here. Point D, point C, point B, point F, point E. And then you also need to understand that these two lines right here are meant to be parallel. They're supposed to have arrows on them anyway, I should say. Okay? So from this diagram, name a pair of parallel lines. Okay? Can you find them? I kind of just gave them away, right? Line DM is going to be parallel to line FE. Can you find a pair of perpendicular lines? What do you think? Well, hopefully you're looking at this and saying, wait a minute, I think line BF is perpendicular to line DM. Right? BF here, DM here. Okay. Next question, is line FE parallel to line AC? Well, AC is here, FE is here. The answer is no, not by a long shot, right? They're going to intersect. Even though you can't see it yet, they're going to intersect. Okay? All right. Moving on. We can draw two lines, right? Like these green lines here. And then if we run a line up to meet those two lines, so if we draw a line that intersects the two green lines and does so at two different points, then that line is called a transversal. So the transversal is the guy that hits the other two lines. Okay? I'm going to use that term a lot. We need to get used to being able to find the transversal. So a transversal is any line that intersects two or more lines at different points. That's what this guy's doing. Okay? Now, when you do that, when you draw a transversal for two lines, then you create actually 8 different angle measures, 8 different angles, right? If we go back, there's an angle here, 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 and then here, 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 and here. So there's 8 different angles here. The first type of relationship, so these are angle pairs, angle relationships, or corresponding angles. Corresponding angles, you're going to find them in 2 different ways. Number one, I kind of like to think of these as Foursquare courts, if you've ever played Foursquare. Corresponding angles are the 2 angles that are in the same position in the Foursquare courts, right? So in the top right court is angle 2 up here. In the top right court of this other set is angle 6. So angle 2 and angle 6 are your corresponding angles. They're not the only ones. If I put a 1 here and a 5 here, then 1 and 5 would be corresponding. Or 3 and 7 would be corresponding. Or 4 and 8 would be corresponding. They're in the same position in the Foursquare court. Okay? I think that's the easiest way to find it. I have done this. If you trace these 2 angles, so here's an angle, here's an angle, they make an F. So any angles that make an F are going to be corresponding angles. Okay? Here's another way to tell. I like the Foursquare thing better, but sometimes we talk about, and you see textbooks talk about finding the F. Okay? Next are alternate interior angles. Alternate interior angles. Interior means inside. So this is the interior, in between your 2 lines. Alternate means on different sides of the transversal. So alternate interior angles are inside the 2 lines and sit on opposite sides of the transversal. For example, angle 4 and angle 5. Okay? And if you trace angle 4 and angle 5, then you make a, well, it looks pretty much like a Z. The angles that form a Z are going to be your alternate interior angles, like these guys. Now, these, again, are not the only ones. There's another set of alternate interior angles, like 3 and 6 here. Those are also alternate interior angles. Okay? Then we've got alternate exterior angles. Alternate exterior angles are like alternate interior, only they're outside the 2 lines instead of inside. Exterior would be out here, needing to be on opposite sides of the transversal. So, for example, angle 1, angle 8. Or angle 2 and angle 7. Those would be on opposite sides of the transversal and on the outside. Okay? Consecutive interior angles. We didn't do letters with alternate exterior because there's really not any letter to talk about. If you trace them, it's not really a letter. I think the name alternate exterior helps you find them. Now, consecutive interior, sometimes called same side interior. So we're back on the inside, and now we want them to be on the same side of the transversal. So, for example, like 3 and 5. Both inside, they're both on the same side of the transversal. Now, if you were to trace these angles, you would get a C. So we are looking for those C's. C for consecutive. Okay? Another way to look at it. Now, those are the definitions. Use those definitions, flip back and forth, and try to find all the angle pairs in this picture. Okay, let's see how you did. Corresponding angles. The ones that are going to be in the corresponding Foursquare courts would be 1 and 5. 2 and 6. 3, 3, and 7. 4, and 8. Lots of those guys, right? Okay. Alternate interior. Inside and on opposite sides of the transversal. So angle 2 and angle 7. Angle 4 and angle 5. Alternate exterior are going to be 3 and 6. And 1 and 8. Consecutive interior, same side and inside, would be angle 4 and angle 7, then angle 2 and angle 5. Okay, so hopefully you're able to pick all those out. Because what I would have you do now is pull out your protractor and measure all of these angles. Before we do, let's talk about this for a second. We still have a transversal right here, but now it's intersecting two parallel lines. Now before, just any two lines could have a transversal drawn through it, right? So here's your transversal, and then your two lines there, okay? Now I want to talk about specifically when these two lines are parallel. So these two guys are parallel, and then we draw a transversal. And so angle 1 is actually 147 degrees. If you were to pull out a protractor and measure it, it'd measure 147 degrees. Now, I would encourage you to stop the video now, go measure all of these angles with your protractor in your notes right there. It's the first example past that postulate, the corresponding angles postulate. So you can verify this for yourself. It's kind of fun. All right, so if you've done that, what you found, hopefully, is that these angle measures are true. So 147 for angle 1, 147 for angle 4, 33 for 2, and 33 for angle 3. Angle 5 would be 147, as well as angle 8. Angle 6 and 7 would be both 33 degrees, and you can verify those with your protractor. Now, take a look at the corresponding angles. Now, when you measured these angles, they might have been off by a degree or two, which is acceptable, just human error. Look at your corresponding angles. They're the same. Every last pair, they're the same. So that leads us to the corresponding angles postulate, which says this. If a transversal cuts two parallel lines, right? If two parallel lines are cut by a transversal, then the corresponding angles are congruent. So angle 1 and angle 5 are congruent here, right? Just like 1 and 5 are congruent here. 2 and 6 are congruent. 3 and 7, 4 and 8. Okay? Corresponding angles are congruent. You can always stop this and continue writing that down if you need to. If you take a look at alternate interior angles, alternate interior angles are also the same. So the alternate interior angle theorem says that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are the same. They're congruent. So 4 and 5 here, right, or 3 and 6 are alternate interior angles too, and they're still going to be congruent. Okay? If you look back at your alternate exterior angles, you're going to find the same thing, that alternate exterior angles are congruent also. But you have to pay attention to the fact that the two lines here, P and Q, have to be parallel. That's the only time this stuff works. Otherwise, if these two lines are not parallel, then it doesn't count. Consecutive interior angles are also, whoa, wait a minute, if you go back and look, they're not congruent. They actually add to 180. Of all these angle pairs that we're talking about, consecutive interior angles are the only ones that are supplementary. Okay? Everybody else is congruent. Okay, so 3 and 4 are going to add to 180 degrees. All right. We can use this to help us find the value of a variable, to find different angle measures, whatever. In this guy, we want to find x. Well, here's what I know. I know that if this is 115 degrees, then because of vertical angles, and yes, vertical angles still exist, we can still use them, then this guy's going to be 115 degrees. I also know that when I trace these, I get a C, which makes them consecutive interior angles. And from the theorems that I just took a look at, I know that those two guys have to be supplementary. So subtract 120, and x is 60. Okay? Just using our different relationships. All right, proofs. We're still going to write some proofs. Now, we're going to talk a little bit more. We're going to start easing our way into writing statements and reasons. Okay, so we're going to prove that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Okay, we're going to prove that theorem. So we're not going to use that theorem. We're not going to use alternate interior angles are congruent. We're going to prove it. We can't prove it by using it. Doesn't make any sense. Right? So, first thing that always goes in your proof is the given information, which is that P and Q are parallel. Now, what do I know because of that, or from the picture? Well, if P and Q are parallel, then I know that angle 1 and angle 3 have to be congruent. And the reason why I know that is because of that corresponding angles postulate. I can't use alternate interior angles, but I can use corresponding angles. Write that better. Corresponding angles postulate. It's a postulate, but the other guys are theorems. Okay? Well, what else do we know? Well, if you look, we actually have some vertical angles, angle 3 and angle 2. Right? And so by the vertical angles theorem, they are congruent. And now you have to recognize that this is transitive. This is statement 2 and 3 is the structure for the transitive property. Or you can use substitution. Either one. We can say angle 1 is congruent to angle 2. And that's by either transitive or substitution. It all just kind of depends on how you see it. But either one would be fine. Okay? And there we go. We've just proven the alternate interior angles theorem. We've shown that the alternate interior angles 1 and 2 are congruent without ever actually using the theorem. So, alternate interior angles are congruent. We're good to use that. Okay? And one more example here. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 has to be 40 degrees. What's the measure of angle 1? Well, they're showing us that these two sort of lines here are parallel. Angle 2 is 40. So what's angle 1? It's 40 also. How do you know? Well, they're forming alternate interior angles for those two parallel lines in the transversal. And we know the alternate interior angles are always congruent. So angle 1's got to be 40 degrees as well. All right? All right, that's it, guys. Homework's out in Canvas. Make sure you have that done by next time.